Hello, everyone. Please comment your name and what country you're joining from. So, hi, everyone, and welcome to day 2 of Teens in AI's Bootcamp week. My name is Hannah, and I will be hosting today's session. Today, we're going to explore the ethical challenges in AI with Morgan and Sabeehah from the Alan Turing Institute, focusing on bias, transparency, and responsible development. Then later, we'll dive into the world of data science with Shanttel, a data engineer at Sage, who will share how data science is driving innovation and how you can build a career in this field. Before we get started, a huge thank you to our corporate partners, Sage, Sage Foundation, and Red Hat for making this event possible. Without further ado, let's get started. If you have any questions, please put them in the Q&A chat, as we will be having a Q&A session at the end. I'm going to hand over to you now.
Wonderful. Hi, everyone. It's nice to be with you today. We're very excited, Sabeehah and I, to be joining you for this very exciting boot camp. Both Sabeehah and I are from the Alan Turing Institute, as Hannah said. The Alan Turing Institute is the UK's National Institute for Data Science and AI, named after Alan Turing, who is really the kind of founder of modern day computer science. So we're really excited to be with you to talk to you a little bit about AI ethics. So to jump right in, I'm going to start a little bit about what we actually mean by AI, kind of what are some common definitions, what are kind of the common inner workings or parts of an AI system. And we'd love to hear from you all as well about AI systems you find in your day-to-day life. I'm going to give an introduction to ethics more generally and kind of how we come to this field of what we call AI ethics. So how we get from the kind of inner workings, the kind of technical of AI plus the ethics to come to AI ethics, which is a really growing field. A lot of organizations are seeing the necessity and the importance of having AI ethics and governance in their companies, in universities, in research institutes. So we'll give you a little bit of insight into that. We'll also give you some key concepts and examples relating to AI ethics and relating to this field. And then, as the bootcamp that you all are taking part in has a focus on several SDGs, we decided we would focus some of our attention towards SDG 4, which is about quality education, and give some examples of kind of how AI ethics considerations could find their way into the space of education and why these considerations are really important. So throughout the entire presentation, we will be using Mentimeter, which is a kind of online poll. So anytime you see a slide with a little QR code and a code, you can join online. We'll make sure everyone has the opportunity to do that. And you can just type your responses. It's anonymous. We'd love to hear from you. And then my colleague Sabeehah will kind of share the results live with everyone so we can see what everyone in the room is thinking. And then we'll have a bit of time at the end for discussion and questions. Great. So what do we mean by AI? So this is kind of a big definition, but it talks about how AI systems are algorithmic models. So they're based on some form of mathematical logic or function, but they carry out functions, we say cognitive or perceptual functions, that were previously reserved for thinking, judging, and reasoning human beings. So the kind of Cliff Notes version, the short version of this is basically AI is a tool that can help us do tasks that we previously thought were only possible to be done by humans. So we at Alan Turing Institute see AI as a helpful tool. We believe it's a tool that can be used across many different sectors, across many different problem sets. But what's really important is at the end of the day, that there's human accountability for the use of these tools. And so we always advocate for human-centered AI. So AI that has humans at the center, that it's responsible for and accountable for by human decision makers. So you might be asking kind of what are some of the building blocks of AI? So most AI models at this stage, there's obviously lots of different types of AI models, but most of them are comprised of three kind of high level basic kind of building blocks, if you will. So all AI models need a data set, they need data. So this can either be collected for the specific problem, it can be maybe scraped off the internet. There are many different ways to gather data, but it also needs some form of learning algorithm. So somehow, some way to turn that data into some type of output. So this is usually some type of mathematical algorithm, some type of mathematical logic that then concludes in some type of output, which could be classifying things. So maybe like if you're thinking like a spam filter, maybe you're determining if an email is spam or not spam, or maybe you're predicting something. Maybe you're using data to see what the weather might be like in a week's time. So there are lots of different types of outputs of AI systems, but most of them generally consist of these really high level kind of building blocks. So one of the main kind of subsets of artificial intelligence is machine learning, which, as the name kind of implies, there's some type of mathematical logic happening in the middle. So I wanted to kind of share with you maybe 6 main kind of takeaways from what we mean by machine learning. And the first is actually that learning is a very misleading term. Because the way we think of learning as human beings is obviously very different from the way that machines learn. So I'm putting it in quotations because at the end of the day, um, what's happening is a system is being programmed to do something, right? So you have your data, you have a learning algorithm, and then you have some form of output. So it's not a consciousness thinking that we would do in our kind of daily lives of thinking of how to solve a problem. We might gather some evidence, we might talk to some people and come up with a conclusion. This is very much in machine learning, it's very much an algorithm centered, rules kind of centered, math centered algorithm happening at the core. So as I said, it applies a mathematical function, but it's also pattern based. So machine learning is basically looking through tons of data and trying to answer some form of question. So maybe looking through the past data and saying what has happened in the past and what is likely to happen in the future based off of the data from the past. So it's mapping patterns in that data. And therefore, it's able to make some predictions. So if the data set was saying, across these 5 months, this thing seemed to happen, we could therefore potentially predict that in those months again, with the limited information we have, that same occurrence could happen. So you can see that it's mapping patterns, and to do this, it requires data. And so, as I said in the previous slide, the data set is really important, and we call this the training data. So this is the data that the model is trained on in order to make that prediction. So you can imagine that that data set is so important, because if you're only having a small segment of the population you're looking at, or maybe it's a really small data set, then you'd be basing all of your future predictions off of something that maybe isn't representative or isn't recent, for example. And so what we kind of refer to this as is garbage in, garbage out. So if you feed an AI system bad data or data that's not representative or not recent, you can expect the prediction to also be in that same type of quality. So maybe not recent, not representative. So it's really important to choose good data sets and to choose learning algorithms that will help you get an output that A, answers the question, but B, does it accurately and responsibly. And that's really where kind of we come in terms of AI ethics. So before we get in a little bit more about the field of ethics, you can see the code here. So you can either scan the QR code with your phone or go onto your browser and type in menti.com. The code is right there, 31111473. And just to ask all of you, what are some examples of AI systems that you may use or have seen? So we'll give everyone a chance to input online. And then Sabeehah, I'll stop sharing so you can pop over. Perfect. So anything you think might be an AI system that you may use in your day-to-day or that you've seen. Cool. Yeah. ChatGPT, Copilot, Apple, Skyspace. Nice. TikTok recommendations, DeepSeek, Gemini. Nice. Lots of good examples. Yeah. Claude. Nice. Great. So it seems like a lot of these examples are generative AI, which is really interesting because this is a type of AI that is quite prevalent at this time um, because the products are quite widespread and easy to use, like ChatGPT. But then we have some really specific examples, which are great. So TikTok recommendation, cancer identification, great. And we'll get into some of those. Let's see a few more. Siri, yeah. Um, Great, cool. Keep adding responses, but this is really great. So it seems like everyone's kind of interacting with or has seen examples of AI, which is a really good starting point for the conversation. So we'll head back to the slides now. Great. So here are some other examples of AI that you might have seen. So this is kind of auto text, kind of population when you're going to text and it's giving you suggestions of what the next word might be. That's a type of AI. Google search engine is AI. ChatGPT, which a lot of you had mentioned, that's great. Smart speakers use AI. As well as YouTube. So similar to I think someone said TikTok recommendations, similar thing on YouTube. YouTube recommendations uses AI. So just a few more examples, but seems you all are very familiar. So before we go into ethics, I just wanted to talk a little bit about some really common AI myths. So the first one is that AI is neutral, objective, and fully reliable. And we know that because AI systems are built by biased humans, that there will be bias across the data lifecycle. And it's something that we have to be really careful about. We have to be really careful about making sure our data sets are representative and that the outcomes are fair. And so saying that just because it's based in maths, it's more objective than humans is not necessarily true because the same bias we have in our day-to-day lives are embedded in historical biases in data sets and also in the decision making when teams decide to build AI models. The second one is that AI will solve all of our problems, and this is often referred to as techno-solutionism. And this is a myth for several reasons. One is that sometimes building some type of technology to solve a really massive problem can often be kind of like a plaster you're putting on to mask root causes and problems, and saying that this technology can solve all of these really long-standing kind of structural inequalities. So it's not to say that technology can't support solving those issues, but obviously it takes more than just a technology or a tool. And also sometimes it risks experimenting with AI for the sake of innovation. So this kind of, let's just see what we can do with technology. And maybe we could have used those resources in other ways that could have had more of an impact. The third myth is that AI can replace humans and make better decisions. And this is a myth for several reasons. One is that, similar to what I said previously, AI replicates past mistakes or biases. But also, there's always human accountability. So, who is responsible when things go wrong with the model? It's whoever built the model or whatever company decided to deploy the model. There's always some form of human accountability and responsibility in the decision making behind these systems. And then the last one, sorry, is that AI will be smart and intelligent enough to take over. And the answer to this one is that we're just really bad at predicting AI. And so that's something we should all remember. We've been quite bad in the past of predicting technology in the future. So it's important for us to keep that in mind moving forward. Great. So I'm going to give now an introduction to ethics, which is its own field in its own right, but kind of what we do in our team at the Alan Turing Institute is we blend this field of ethics and this growing kind of interest in field of artificial intelligence into this really kind of interesting cross section called AI ethics. So this might look a little bit daunting. I don't know. I'm a big flowchart person, so I like when things are in boxes and look like they're flowing in one direction. But I don't expect anyone to have seen this before, but it's just really a high level intro. I have formal training as an ethicist, so this is really interesting to me. Is like why we determine which things are right and which things are wrong. So when we start all the way from the beginning, we look at what we call meta ethics, which is really the nature of ethics. So where do all individuals have different answers to these questions, by the way. This is quite a subjective thing, ethics. Meta ethics basically asks, where do we have the basis for what is right or wrong? So some people might believe this comes from a set of rules that were determined a long time ago. Maybe some people think it comes from certain religious practices. Maybe some people think it comes from culture. These are all different basis points, starting points for how to even begin to determine what is right or wrong. And then we move into the content of ethics, which we refer to as normative ethical theories. So this is really how in our day-to-day we determine what is right or wrong. So once again, my perspective on this could be completely different from my friends, my colleagues, from all of you. But there are usually four main kind of categories. The first is called deontology, which is like a rules based. You follow a set of rules or principles to guide whether or not something you think is right or wrong. Consequentialism, sorry, the M has run off on its own adventure there, but consequentialism basically means the consequences are what is most important. So it's not necessarily about how you get to an answer; it's about the end itself. So one of the most common forms of consequentialism is called utilitarianism, which is like, as long as the greatest good for the greatest number of people is achieved, it doesn't really matter the kind of process to get there. It's about the outcomes. Virtue ethics is about prioritizing a set of virtues that you believe kind of are really important and should take prevalence over many other things. So, for example, if I prioritize honesty as a virtue, I might determine what is right or wrong based off of making sure that I'm honest in that situation. That's how I would kind of make that determination. And then finally, we have biocentric ethics, which is prioritizing the biosphere, prioritizing the flourishing of nature. So you can see these are kind of, this is not all of them. This is just four ways that people might make the determination of whether something is right or wrong. And so all of this leads to what we call practical ethics, which is actually, what do we actually do if we are given a situation? So you might be thinking, how do we basically take all of this information, take all of the people in the world who have very different perspectives on this, and boil this down into something that can actually be quite actionable? And that's where we get into AI ethics. So AI ethics is important for several reasons, but we want to hear from you what you think, and then I'll answer that question that I left you on a cliffhanger of how do we actually get there. So feel free to type your response. Why do you think we need AI ethics? Okay, so we have to regulate language used by people. Be interested to know if that's in more of a platform basis or what kind of is meant. Feel free to type. I think you can type twice, so feel free to type another one as well. You can answer us on every question. Okay. Why else might we need the field of AI ethics? If you think about all of the AI uses that you all mentioned in your daily life, why do you think it might be important to have some type of consideration of ethics? We'll give it a few more seconds. This is kind of a tough question. Keep humans at the center, to stop people being harmed. Yeah, these are good answers. We have some thumbs up in the corner. A lot, it looks like a lot of thumbs up. They're flying off the screen. Okay, great. Less bias, data still is our bias, they used to use it responsibly. Yeah, these are all really fantastic. Great. Make sure how to use AI morally with responsibility. Lots of stuff about bias, responsibility, stopping harms, keeping humans at the center. Great. Fantastic. All right. Let's see what we think on this one. Avoid bias and harmful stereotypes. Oh, ensure fairness. Oh, they're still coming in. These are so great. Prevent harm, bias, and misuse. Fantastic. Structure data and help teachers. Wonderful. Thank you all for engaging with that. We'll come back to this, I'm sure, in the discussion. All right, Sabeehah, if you switch it back. Perfect. Thank you. Okay, great. So why do we need AI ethics? And many of you touched on a lot of these points, so thank you for that. The first one is that technology is socio-technical in nature. What we mean by that, it's kind of a big word that I hadn't heard until I moved into this field, is that technology doesn't just exist in a vacuum. It's designed by humans. It involves data about humans, and so because of that, we need to think about questions like what should or should we not do in a given context. And also, in what context or for what purposes should AI not be deployed or be deployed? So, if we're thinking of like safety critical sectors, maybe in like healthcare, are there certain use cases where maybe AI is not the best answer? These are the types of questions that AI ethics helps us to answer. And also, finally, it's important to note that it's not the same as legal compliance. So, we have GDPR, we have data protection, which are really important. But those are obviously things that are mandated that we must do. And it's not the same as thinking through problems and thinking, should we or should we not do this? What are the impacts on people? That has more to do with ethics. So as I said, I kind of left you with that big question of how do we join together the fact that individuals have very different opinions on how they determine what is right or wrong. How do we move from that to actually being able to do something in practice? And the way we do that is we think about potential harms that could result from an AI system being misused or developed in the wrong way. So a few of these examples are things like bias, injustice, discrimination. We also have like breaches of data integrity, privacy, and security. And then loss of human connection and empathy. This is something that might happen, for example, if a person thinks they're engaging with another human being, but actually they've just been engaging with an AI chatbot. That can be quite dehumanizing in a lot of ways if it's not made clear to you. And so we start from this point, also using grounding in human rights. So we do a lot of work with the Universal Declaration of Human Rights to look at how to prevent these harms. And the way we do this is by making certain principles very practical and allow them to be measured in the design, development, and deployment of AI systems. So if I say AI ethics often focuses on key principles, do you all think you could think of some examples of what some of these principles might be? And a few of you have said some of them already. So there's no wrong answer by any means, but feel free to share on Menti. So these are, you just do one word principles, try to think of as many as you can. Some AI ethics principles. And if we get stuck, maybe Sabeehah and I can give you an example of one. Transparency, great first one. Yeah, fantastic. Really important. All right, let's see what others think. It's a really strong start. It's a bit of a tough question as well. So we're giving you a bit of a challenge with our Q&A today. Accountability in the chat. Thanks for that. Perfect. Yeah. Unbiased, fairness. Nice. Perfect. Common sense. I like that. Yeah, that's awesome. I would completely second that as a principle we should have. Unbiased again. Morality. Yeah. So morality could also link with maybe fairness as well. Great. See if we can get a few more. Privacy, trust in the chat. Great ones. Humanity. That's nice. Privacy, fact checking. Nice. Fairness in the chat. Awesome. I think you all have seen the slides already, huh? Accountability, nice. Yeah, beneficence, very good. Great. Well, this is a really solid start. You all are going to see in the next slide that you've captured a large amount of them. Great. I think I saw clearness at the end. I like that. I think that has to do with transparency too. Great. So back to the slides. You all have mentioned, I think, almost all of these. So well done. Privacy, accountability, safety and security. I saw transparency, fairness. Great. So these are kind of there's lots of principles, but I would say these are kind of the core principles that continuously come up and are kind of the centered principles for AI ethics. And what this allows us to do is kind of action these principles. So we can say, in order for an AI system to be, insert principle, transparent, for example, we want to make sure that the decision-making behind the data we chose, behind how we processed it, is made clear to the end user. That could be one example. So there are ways to, we say, assure, which basically just means make sure these principles actually are enacted throughout the AI lifecycle. So that is one way that we kind of reconcile kind of people's personal views about ethics and the field, is by focusing on harms and then using the principles to prevent those harms. Great. So I'm now going to pass over to Sabeehah to talk about some key concepts and examples related to the field of AI ethics. Over to you.
Thanks, Morgan. So now you've heard all about what AI is and also what AI ethics is and why it's needed. And we touched briefly on what the principles are. So now we'll look at some real life examples and also what are the real world implications if AI ethics is not considered. But before that, I'd like to show a short video with you about AI ethics.
Perfect. I think I have to unmute. Let me just double check really quick to make sure we have sound, but Sabeehah, you can tell me immediately.
When people wonder what is AI, they think about robots.
Robots.
Let's make a distinction. The robot itself is hardware. AI is software.
What is artificial intelligence? Systems that mimic, perhaps even go beyond our own ability to think and to process information.
It determines who we want to date, whether we get a certain kind of loan, operating at all levels of our economy, in the political realm, in the judicial system, employment practices, in the educational system. All of these decisions help to determine how well or how poorly our lives go, and increasingly, AI is involved in those decisions. We are right to be concerned when we are just now learning to think about the social and ethical implications of using AI.
So many of our own stories are about the relationship between the creation and the creator.
So we're at this inflection point right now. Suddenly, all of this data, these algorithms, and the computational power is available.
And that's really been the breakthrough.
Things are becoming real that we've talked about, we've dreamt about for decades. AI which can do a very specific, narrow task.
That can recognize voice, navigate a car, translate language. And if this is going to be the ubiquitous tool,
We're doing ourselves a disservice by not educating the general population also on what is really going on right now.
We have so many immediate concerns about the kind of AI that will be developed that we really need to devote most of our educational efforts to those kinds of problems. Artificial intelligence uses a massive amount of data to recognize certain kinds of patterns that are correlated with a successful result.
Hidden in these vast pools of data that we're now using are remarkable opportunities to run off the rails.
So we have to be careful about the data we give it.
Data can be bad because it's not been properly labeled, because it's inaccurate, because it has baked into it certain human biases that are naturally a part of society.
One clear example of data bias is the use of algorithms to make decisions about the fate of prisoners.
If you have enough data points, you should be able to judge a person's likelihood of reoffending. Well, the problem is,
if there is bias hidden in the data, your outcome in the judicial system may be very different than someone who's upper middle class and white.
Why is it projecting higher risk scores onto Black defendants? It often turns out that the algorithm itself isn't feeding on any data that's explicitly labeled in terms of race. A zip code doesn't tell you anything about a person's race. What the machine learns is, people in this zip code are more likely to be criminal, when in fact it may just be that they're more likely to be Black or poor or any other category that is a subject of biased practices.
These technologies will actually reinforce some of the worst aspects of our society, which is really a great tragedy because the technology has the potential to actually do exactly the opposite.
Machines aren't racist. Machines aren't sexist. Machines aren't ableist or classist. We are.
That's a picture of a cat because of the ears and the tail, the whisker and the nose and all that.
the machine itself starts to recognize that such and such is a cat and such is not a cat.
We don't actually know how the circuit has reached that particular set of conclusions.
Hot dog, not hot dog, whatever. That's funny. Fire missile, not fire missile. That's not funny.
What I see is a generation that takes all kinds of life instructions from its device, whether it is where to go to eat Korean barbecue or who to marry. It all comes magically out of the palm of your hand from an algorithm that you know nothing about.
Who's behind that screen? Who's on the other end of the wire?
What are the motivations of the algorithm? People no longer even think to ask. It's just so convenient.
That ability to predict and then modify our behavior, perhaps even without us fully understanding why or how.
If you want the machine to behave in an ethical manner, you have to know why it does what it does.
We must develop responsible and safe practices before the power gets too unmanageable for us to control. Whose responsibility is it? Is it corporations, government? Is it society? And it's really all of us.
There would probably be scientists and technologists who say, I'm not going to let any consideration stop me from my investigation of the world we live in. We all have to together say, is that a road we want to go down?
Human responsibility for human power.
Well, I hope you found that interesting, and I think there were some important questions and considerations that were highlighted, including how an algorithm works, but also possible implications of incorrect classifications and predictions. And you can watch the full video if you are interested on YouTube. So now moving on to algorithmic bias, which is one of the impacts and outcomes if AI ethics has not been fully considered in the design, development, and deployment of AI systems. So before I get into this, would anyone like to share what do they think algorithmic bias means, or maybe share an example? You can type it in the chat. And while I give you a minute to think about that, feel free to keep sending in any suggestions or ideas in the chat. So I'll briefly explain what algorithmic bias is. So an algorithm requires input data to produce an output, and this is something we've been talking about throughout today. Now, algorithmic bias simply means that the algorithms are trained to identify patterns from data sets which are either incomplete or biased, and therefore produce outputs which unfairly favor some groups over others. These biases can sneak into our everyday technology like search engines or social media feeds without us even realizing it. So if we look on the slide here, you'll notice that the bar graphs shown here indicate how often AI often links men with higher paying occupations than women. And if we think about what would the real world implication of this be? Well, firstly, it would negatively affect the way women and young girls think about themselves. But it may also influence the opportunities that are shown to women. And these may be different to those that are shown for men, because these are influenced also by our search patterns and what we see based on the algorithm. And so this could ultimately result in limiting career advancement for women. But also, further than that, it could potentially lead to exacerbating the gender pay gap. And if we also think about the users of AI systems, for example, in 2023, Statista found that male users of ChatGPT represented up to 65% of total users. And so that means women were made up probably only about 35% of the total users. And this if we consider just in terms of the audience of these systems and the information that they are receiving, then if biased content is generated and shown to a largely male-dominated audience, there is a significant risk of perpetuating inequality and reinforcing stereotypes. If we move on to the next slide. So another impact, unfortunately, of not upholding AI ethics principles is that of discriminatory outcomes. Now, for instance, the middle article by Stanford Law on how will AI impact racial disparities in education So this article discusses how universities that use AI enrollment algorithms may use past application data, which includes test results, zip codes, socioeconomic status, and other variables that are not usually disclosed to determine funding and future enrollments. Now, even though these categories are race neutral, similar to what we heard in the video, where race is not specifically identified, is not specifically a category in the data, the outcomes may still be discriminatory. And this would happen for instance, because in this particular example, Black and Latino students have historically scored lower on the math section of the SATs compared to white and Asian students. And so the AI algorithm may allocate more scholarship funding to white and Asian students rather than Black and Latino students. Another implication would be in terms of access. So not everyone has the same access to AI, and specifically in terms of in education. And this really has a significant risk in terms of inequality. So, for example, students in rural or underfunded schools may lack access to AI-powered tutoring platforms and even just learning about AI, while wealthier institutions can integrate these topics and also these technologies into their education syllabus to enhance learning outcomes. Now, this further widens the gap in the education system, but also this applies to children and youth all around the world, where some students will receive more help and have a better chance of succeeding in their careers, and others won't. And then moving on to the next slide. So it's also really important to consider the real-world implication of biospheric harm. And ignoring the ethical and responsible use of AI, it may not only harm humans, as we've just been discussing, but it also can have a significant negative impact on the environment. Now, biospheric harm is often spoken about less in the media than some of the other examples that I just shared with you, but is equally, if maybe not more important. For instance, one study found that training Google's main large language model produces emissions equivalent to that of a transatlantic flight. And the training of GPT-3 used approximately 700,000 liters of fresh water. So amongst the hype of the benefit of these technologies, it is important to remember to weigh the perceived benefits against the impact to the environment. Another example is one conversation with ChatGPT generally uses around 500 moles of water or the equivalent of a plastic bottle of water. And if you think about the impact that this would have on the environment and the number of ChatGPT users around the world, it is really significant. Unfortunately, when it comes to biospheric harm and climate change, those communities who stand to benefit the least from these AI systems are often the ones most at risk of being impacted by climate change. So when you think of AI ethics in the real world, I'd say remember that when it comes to AI, lines of code are what shapes people's experiences, and people's experiences ultimately shape their lives. I'll pass back to Morgan.
Thanks, Sabeehah. So as Sabeehah has illustrated, we've just given kind of 3 examples, which is not exhaustive by any means of AI ethics, but it just shows you kind of really concrete examples of the types of things we work on a day-to-day basis. So, our daily work at the National Institute for Data Science and AI involves really trying to make sure that where AI tools are used, that they don't exacerbate inequality, that they don't contribute to negative aspects of damaging the environment. These are real things that we're working on, and to us, it's really important that this field continues to exist and does exist as a career opportunity for folks who are interested in technology, but also really interested in kind of the societal implications of technology. So the last part of the presentation, we're just going to zero in a little bit more on, as I said at the beginning, SDG 4, which is about quality education. So before we give a little bit about how AI ethics might be related to this space, we wanted to hear from you about some potential ethical considerations for AI systems that might be introduced into the education space. So I'll let Sabeehah share again. You all have been so great with the poll, so thank you. Keep it up. And thank you for everyone typing in the chat and the Q&A. These are really great questions and comments as well. We'll hopefully get to some of them at the end. So what do you think might be important to consider if an AI system is going to be deployed in an education space? What are some things that you might consider if you were the one developing the system, or if you were going to use the system in an education space? So we have plagiarism rules, important, harmful bias, two important ones. Maybe you can think about if your school is using any AI tools, or if they're thinking about it, what are some things that might be important to you for you to know, or you to be aware of if you are interacting with the tool at school? Fact checking, human feelings, jobs for educators. Yeah, this is approaching lots of different angles to this topic, which is really important. And also something that's really important in the field of AI ethics is trying to approach it from a lot of different viewpoints and angles. Learn to understand AI more. Filtering harsh language. Yep, so that's kind of around safety. Yep. See if we can get a few more, and then we'll go back over to a bit of a discussion. Crafting different types of teaching. Yeah, that's a really important one. There's a lot of potential opportunities for personalized learning. Yeah, AI benefits all students, including those with disabilities. It's a great point. That gets to the point of fairness, inclusivity, really important. Great. Maybe for the sake of time, Sabeehah, we might go back to the presentation and then we'll have time for discussion at the end. Great. So just to say a few, these are just some of the ethical considerations, but there are lots of different ones, and sometimes you might find one topic more interesting than others. So obviously Sabeehah had pointed to carbon emissions and water footprints. So when we're thinking of things, especially with generative AI, things like ChatGPT, we have to be mindful of the potential impact on the environment. There's also a lot of data privacy and data collection concerns, especially relating to young people, of how the tools that are deployed in educational spaces might be collecting data on young people, sometimes without their consent, but also to train future models, especially if young people think that information is to be kept confidential, and then it's not. That's a really difficult challenge to face. There could also be, I know a lot of you folks had mentioned bias, but as Sabeehah said, depending on how the models have been trained and who's using the models, it might perpetuate really harmful stereotypes about certain groups of people, about certain jobs, about certain geographies, cultures, etc. So it's really important for us to be mindful of how tools might continue kind of already existing discrimination. There's also the concern that some teachers have that the AI tools will create lessons that are interesting, but they're not necessarily aligned to national education goals. So they might be really interesting and informative, but they're not actually helping young people prepare for their assessments, for example, because they haven't been trained on maybe the entire curriculum, for example, or the objectives of the curriculum. As Sabeehah had mentioned, and others have mentioned as well, there's also the fear that these tools could widen the digital divide, which means that the schools that have access to AI systems might have more access to learning opportunities than the schools that may not have internet access or may not have access to the tools. And that's a big ethical consideration, I think, that we always have to keep in mind. A few of you mentioned kind of harmful content. It's a really important one because we know that almost all of these tools have not been developed with children in mind as users. So if we have young people accessing tools that weren't developed for them, there is a tendency that they could come into contact with quite harmful and not age-appropriate material, which you can imagine would be quite concerning in a school environment. We work a lot with young people, Sabeehah and I, and one of the main concerns that has kind of always been brought to our attention is students' fear that it might limit their creativity or affect their creativity and problem-solving skills if they're always able to kind of pop something into ChatGPT and get an immediate answer? What are kind of the long-term effects on how they think through problems and try to solve problems themselves? And then the last kind of few are sometimes when we try to solve one SDG, we might end up negating progress towards another one. So for example, in this case, perhaps there are some really, really positive impacts on and progress towards quality education by, for example, allowing personalized education that helps neurodiverse students learn in more effective ways. But at the same time, perhaps it might cause kind of harm to the SDG relating to solving climate change, right? So you can see there's always trade-offs with how we kind of progress towards SDGs. It's just something to be considerate of. And then a few of you have mentioned transparency and consent. So if these tools are used in education spaces, did the young people and the parents and carers and teachers consent to those tools collecting data? And is that data collection transparent? Do people know how that data is being used? And then global justice is a very similar kind of point to the digital divide, but Sabeehah made a really interesting point and a really important point about how those most impacted by climate change often don't get to receive any kind of benefits from the AI tools themselves. And I think that's really important to think about when we think about AI in the education space as well, is how are we making these tools inclusive and able to be used by the largest amount of people out there, while also being mindful of the ethical considerations. So just to say, they seem like a lot, and I think what's really important for us to stress is that we believe that AI can be a tool that's used for good. We really fundamentally do believe that. But it's really important to be mindful of these considerations from the outset. And so some of you might end up being AI developers or AI engineers or anything of that sort, which is so exciting. And I think, you're going to be the ones that could be in a room having this conversation saying, hey, did we think about potential biased outcomes of the model? How can we make sure that doesn't happen? The more we have these conversations, the more we can actually use AI as a tool that's beneficial for people. And so our job is really to help data scientists, to help AI engineers, to help project teams use AI in a responsible way. We're definitely not saying don't use AI, the whole tool is horrible, never use it. We're not saying that at all. We're just saying you have to be really responsible and accountable for the outcomes that may come from using these tools in domains that affect people's lives. Like Sabeehah said, these are real impacts. And so our job is both very interesting, but also, we have to be really hopeful that we can use these tools to provide benefits. And we know that you all share in that belief, which is really exciting to us. I wanted to pose a question and just ask you all what you think the future of AI ethics might look like. And then we'll just end with a video that I'm excited to show you of what some young people think about this topic. So Sabeehah will share one last time on this. So we have governments will enforce ethical AI use. That would be a positive outcome. That's great. What do others think? What is the future? More laws on AI? Mm-hmm. Hopefully better. Yeah. I think it's always important to be optimistic and try to improve the whole domain. Strict and effective. Okay. People won't worry about privacy breaches. Yeah. Virtual solutions in here. Usage with responsibility. See if we can get a few more. Oh, nice. We have a big answer. I'll read. Regulatory frameworks, enhanced transparency, interdisciplinary collaboration. That's great. Great, interesting. All right. So someone's saying it won't be as accessible as of right now. Be appropriate use, open data, open models, policies and practices that improve the use of AI without taking away creativity. Yeah, these are really great. Thank you, everyone. Awesome. More accurate. Nice. Cool. these are really great. It's nice to see the hopeful attitude and towards the future. I think that's always really important, and it's, I think, something Sabeehah and I consider every day is how we can keep making impacts in the space. So I'll share one last time, just to say, make sure we have time for discussion. Before I play this video, just to give a little bit of context, Sabeehah and I at the Alan Turing Institute, we hosted the world's first Children's AI Summit just a few weeks ago. And we put together this film with a really fantastic film production company that really showcases some young people's thoughts from the day centered around education, mental health, and the environment. And you might share some of these opinions, you might not. But we thought we would share what some other of your peers are thinking in the space. And we have a manifesto that was produced with children that you can definitely read to see kind of what are some of the calls to actions for world leaders. So I'll play the video, and then that's kind of, I think, the end for us. Here we go.
We do know what we're talking about. We are living through it right now, and we have a pretty good understanding, as pretty much as soon as we were out the womb, we were born in the world of AI.
You may be the ones making the decisions, but the consequences are being suffered by us.
Exactly.
So please consider the youth, consider our safety and our jobs, our rights,
our mental
privacy,
health.
And mental health, yes.
Children are finally getting their voices heard when it comes to AI. The goal of this summit is to get everyone involved, kind of share their message with the world as well.
AI is being developed so quickly in a way that is so hard for corporations and our own government to catch up with how the AI is developed.
We should have rules for AI. We need to make sure that it is able to do amazing things that it can do, but make sure that it is not used in dangerous ways.
As some young people are more deprived than others, and the digital divide is also a problem, having AI to bridge that gap between young people around the world would definitely be a big impact on everyone.
If it were overused in the education system, then it would take away valuable social interactions between students and teachers and mentors, and might give people an over-reliance on these easy, quick resources.
AI won't be there to take our exams for us. It can help us along the way, but it will not always be there to go on that journey for us.
Could there be lessons directly on AI to recognize what AI is, how to use it, but how to use it safely?
Mental health issues are rising a lot. Having an AI chatbot maybe just to talk to, and knowing that that information won't go anywhere is going to be so helpful. I don't think AI will ever be able to replicate the creativity and imagination that humans have.
Humans can understand each other, and I know it may seem a lot like AI can understand you, but it can't, because it's a machine.
AI does have a big carbon footprint. You've got to be careful about that.
Try and minimize the damage that the AI does to the environment, for example, its water use, its waste products emitted, and try to minimize as much as possible, if not eradicate it completely.
A very important way it can make the world a better place is by enabling humans to do more, to think faster, and to explore new concepts and technologies, making humanity a stronger, better people than we already are.
Please listen to the teenagers, listen to the children, because these are going to be the people that drive our future.
We stand on the brink of an era that is defined by artificial intelligence.
However, I feel that the very people whose futures AI will determine do not have a say in how it is used. We are speaking to you because we have been thinking a lot about artificial intelligence, or AI.
Its potential to transform education, healthcare, and climate change is enormous.
We would be incredibly grateful if you would acknowledge and put our thoughts into action, as we believe this will help our community on Earth and the generations to come.
Thank you all for your time and for inviting us.
And sometimes we do wonder what Alan Turing would think of AI today.
Great. So yes, we encourage you all, if you're interested, to read our Children's Manifesto for the Future of AI, which you might find interesting. You might relate to some of it. but we would also, love to hear from you. So thank you so much for engaging with us and for being so participative in the polls and everything. It's been really great to hear your thoughts and opinions. So yeah, thank you on behalf of Sabeehah and I. And yeah, we're excited for some questions.
Thank you so much to both of you for that amazing presentation. I'm sure everyone's learned so much today. We already have so many questions, so I'm going to start the Q&A session now. Starting with the first question, can the growing success of AI in coming years affect the relation among humans?
Yeah, it's a really good question. I mean, I think for these types of things, it's really important to kind of do the research we're doing where we're engaging with young people, for example, because young people like yourselves are really the only generation to grow up in the world of AI. I mean, Sabeehah and I experienced it kind of later on in our lives, but we didn't have it in schools when we were your age. So in terms of kind of human relationships and those bits, these are still things that we're trying to really understand because AI is growing, but it's only been with us in kind of a commercial way, and that's been accessible by lots of people for not so long. So the work we're doing in schools, for example, is really trying to ask young people, if they feel like it's having any impact on how they engage with their peers or how they engage with themselves and how they think of themselves as well. There's a lot of stuff around kind of self-confidence related to AI and how to form friendships and all of these things. So we do think there will be some form of impact just because with every form of new technology, it does impact in some way how we relate to the world and how we relate to each other. But in terms of kind of concrete evidence, we're still really waiting to kind of see with kind of the longer AI is around. But what's really important is making sure that, for example, it's really clear when you're engaging with an AI system, because these do have long-term impacts on kind of self-perception and how we form relationships. If we know that we're engaging with an AI system versus another peer or a human is really important. Sabeehah, I don't know if you wanted to add anything to that one.
Yeah, I think it's one of the most important questions that honestly needs to be considered in how these systems are already being developed. And like Morgan said, I think the answer will come with time. But I think we can already see certain things in society already. So the way these systems are being designed are intentionally being designed in a way that keeps people continuously using them. So it's designed in an addictive way. And this is done, this is done intentionally, thinking about certain chemicals that are released in the mind and designing in a way to keep the user engaged for the longest possible time. Now, would that mean that people are engaged on these platforms, speaking to other people? Would that mean that this is taking them away from other social interactions that they would have had if they were not on these platforms or, using these devices? And I think we can already see that around us and even individually for ourselves and observe the differences in behavior. And I think that's really the important thing is be aware of what's going on around you, how you're spending your time and those around you as well. And yeah, the main answer we'll know in the future, but it's definitely something to think about both on an individual and a group level.
Thank you so much. Unfortunately, due to time, we'll just have one more question. Machines are fair and lack the ability to bias. Is it an advantage or disadvantage that AI has no sense of human feelings or empathy?
Yeah, so I think that's an interesting one, and it gets back to that myth around kind of AI systems being objective and fully reliable. And I think as nice as it would be to say that AI systems are fair, we actually can't say that with any real concrete evidence, just because we know that the outputs of AI systems do have the ability to produce biased outcomes, and that's because of several reasons. It's because it's built by biased humans, but also the data that is often used to train these systems is also biased. So the outcomes of AI systems, unfortunately, do have bias in them and are often unfair. So in terms of the second question about empathy, I think, that is one of the most important parts of being human, in my opinion, is the ability to have empathy and connect with others. So I still think that will always be an advantage on the part of human beings designing these systems, and will hopefully make us be able to create fairer systems. So just to say, I think that's why kind of this field is really important, is to try to minimize the bias and disadvantages to groups of people and to all people. Sabeehah, did you want to add anything to that?
Amazing. Thank you so much, Sabeehah and Morgan. Thank you for being here today. I'm going to now introduce our next speaker. I'm so excited to introduce Shanttel. She's a data engineer at Sage who will guide us through how data science is transforming industries, and she'll also share her career advice for aspiring professionals. Over to you, Shanttel.
Hello, everyone. My name is Shanttel, as Hannah just said, and I am currently a data engineer at Sage. But my career has sort of moved through all the data science and data functions. I started in university as a computer scientist, then I got a job teaching data science, then I joined Sage as a machine learning engineer, and now I'm a data engineer, which means I focus a little bit closer in the a bit more earlier in the data science cycle, but I'm still overlooking all of AI, and I'm still coding our AI systems today for our products department. So that's a little bit about me. In this session, we are going to be looking at the data science lifecycle. But we're only going to focus on the section around collection all the way to around visualization and analysis, because I think I can spend 5 hours talking about every single section of it. But I think we don't have that much time today. So let's get into it. What is data science? As we've heard from Morgan and Sabeehah, data science is like a mix. I see it as data being the salad bowl, right? And within my salad, I have knowledge of the subject area. So this is your context. What is the data situated in? Also programming, because as they were saying, we've got to a stage where we have so much data and so many complex problems that we need a bit more computational resources to actually get into the data and what it's saying and what we can do with it. So programming is a big part of our AI journey and data science journey, but also a little bit of maths and statistics, because though we have the data and though we have the resources to compute it, we need to make sure it's saying what it's saying. And so we employ maths, and specifically the statistics branch of maths, to understand exactly what the data is saying and how we can apply it into real life. And our data salad is what is used to make informed decisions, predicting trends, and also improving efficiency, just as Morgan was saying. So in my role, I take my data salad and bowl, and I help our organization, which is Sage, to make decisions and also predict trends. So we have decisions such as, should we have this product on this month or not? Or predicting trends as in, this product is getting really popular, should we push this in terms of marketing? Or also improving efficiency. What if we find that one section of our product is not really that helpful to our consumers? So should we just remove it? That kind of thing, data science can tell us, and I work in that section to do all of that. It was also mentioned by Morgan about the different subsets of data science, because as you work in this industry, you're going to hear these words kind of almost used interchangeably, but there is a difference between it. You can think of my white space of my presentation as data science. And within data science, we have artificial intelligence. Within artificial intelligence, we have machine learning and deep learning. So AI is used to basically describe everything, and that's what it is. And machine learning is a subset of AI, just like Morgan said. And a lot of the work that you do as a professional will probably sit within machine learning, because those things are a little bit small. I say smaller, I'm still talking about like a large amount of data. So take that with a grain of salt. But with machine learning is where mostly your statistics lives, your trends lives, where you're predicting all these things. So if you get a job as a data scientist, you're most likely going to live in the machine learning area, but you may also get to live in the deep learning area, which is a subset of it all. And it's where we get our really, really complex systems like ChatGPT and the like that lives in deep learning. So that's the difference between the words. But like I said, people use them interchangeably, but now you know the difference, which is great. Also, by the way, if you want to put comments in the chat, that's absolutely fine. I love a good chit chat, as you can tell. So comments are absolutely great. If you just like the shade of blue, if you've heard of something before, things like that, and then questions go in the Q&A. Amazing. So where is data science? In the Mentimeter that you gave before, I could see that you know where Mentimeter is. You know where data science lives. Data science is in, I would say, pretty much every industry. I wouldn't say it's in every corner of the earth. I think that's a bit too much, but it's definitely in every industry. You guys gave examples before about like healthcare, finance, social media, also aviation, retail. You know, I work currently in, well, Sage does accounting and like HR products, which is very corporate-y and stuff like that. But I've been in organizations where, you know, you're playing games, they use data science. Education, I use data science in there as well. So it's very, very pervasive in our society and it's here to stay. That's pretty much the message of this slide. So I've given a quick rundown only because you kind of heard about it before with Morgan. So I assume you guys are experts in it. Well, here's my bread and butter of my job, the data science lifecycle. I use this all the time. This is pretty much my job in a wheel. And this is what all of data science kind of looks through. I would say specifically like machine learning, but you can definitely apply this to all of data science. So first things first, we can start at the top. Right here, you can follow my pink mouse. And at the top, we always start by framing the solution or the problem. What are we actually trying to achieve? This needs to be very clear because this informs what we do in the next stages. So we really spend a lot of time, I say me and my team, or you and your team, can spend a long time just defining the problem. Because what is the problem? Why are we doing this? You know, do we have to? That's a good question. Do you have to? And these are where ethics also play a role in it as well. Do you have to do this? Will this help anything? And if we do have to do this, what kind of solution can we start with? Where do we get our ideas from? You know, what is the end goal that we want to produce? So we spent quite a lot of time on this section. And I'd also work with our ethicists and our governance colleagues here at Sage to really make sure that when we're framing the problem, it does make sense and it's necessary and it's compliant as well. So ethics is in every single step that we do. And I do think it should always be there. The question should always be questioned and answered. After you've kind of got what you're doing, the little problem statement, you know, you've got maybe we're going to try this, or we want to end up with this kind of end product. We now start looking at collecting data. This is where I mostly sit now in my role, in terms of collection and processing data. And this is a big, big chunk because we still have ethical questions here. Where are we getting the data from? What kind of form does the data come in? How long can we keep the data? Can we transform the data? Is it saying what we want it to say? Do we need to pay for the data? Do we have access to this data? Things like that. It's really a big part of your entire journey because before you can get to training models, you need data to train models. And if you don't have the data, you're not going to have a model to train. So collecting data and what kind of data you can and will collect is very, very important. Next, you have to process that data because data is literally information. If it's information about anything, it's data. It can be videos, voice notes. It can also be rows and columns in like an Excel spreadsheet. It could be so many different things. So can I use that data in my model? That's where you start processing it. So also thinking about like, is the data even clean? Does it have missing parts? Is it just 2 data points when I need to commit a model that needs like 3,000 data points, things like that. So you've collected your data. Is it ready for modeling? This is where you start processing it. But you've collected your data, you've processed it, it's ready to go into whatever model you think you're going to use, or it's ready to like be on your big programming screen with a black background. And before you can start modeling, you need to know what the data is actually saying. Because a lot of the time you collect data thinking, yes, for example, I'm going to investigate the effect of area. Yes, the effect of area on favorite colors, for example. I'm literally just thinking about this, okay? This is freestyle. So the effect of area on favorite colors, you've collected it, and then you analyzed it. Yep, you got to this bottom of the cycle, and you realize that actually, favorite color is not determined by area. It actually has no bearing at all. You would never have known that if you hadn't analyzed it first to see what the data is saying. So that's why we have to analyze our data before we even put it into any sort of model to see what is the current real life situation looking like before we start predicting things because of it, or making statements and making judgments and decisions because of it. What is it actually saying first? So you've analyzed your data, you've realized that actually area has no bearing on, on what do you call it, on favorite color. So then what do you do? Any comments about what do you do now? Now that you've seen that, it has no bearing on it, what would you say that you would do next? We're in the analyze data section. You can put it in the comments below. Let's say that you want me in my job, you've put your glasses on, you've come to your computer, you've opened it up, VS Code, amazing. And then you click the button that says, run it. It runs and it's like, actually, area is nothing. What do you do now? A, panic. Because that's also fine. You're allowed to panic. Like, you're allowed to. No one's going to say don't panic. But are there any ideas of what you might do next? We could panic. That's also path A. One thing you could do is just stop there and just end the research project. But what we happen is we go further back in the life cycle actually and rethink our problem solution and problem statement. Because it's a cycle. You could go forwards and backwards. So we go back to our solution and problem and think, if it's not area, then what is it? And that's where we change it again and go next to the data collection. Like, okay, maybe we don't focus on area data. Why don't we look at, let's look at height data. Maybe the height of a person determines their favorite color. These are just hypotheses that we are looking at and investigating to see if they're true. So we've gone through it again, gone through and analyzed our data and realized that height does make a difference, because we've done some also clever statistics and find that height makes a difference. But which height determines what favorite color, that's when we give it to a model. That's when we give it to AI to start determining those relationships, but also predicting those relationships. So after you've done that, there are several statistical ways to evaluate your model to see if, number one, is it true to the data you gave it? Did it literally just make it up? Is it given random results? Because it can do that sometimes. And also, is it actually just a good model for the data you have? There are many, many evaluation methods, but we need to do that before we get it into deployment. And deployment is a word that low-key I learned on the job because I had never really learned about it. I thought once you're finished your work, it's on your computer and people just huddle around your computer and just look at it. But no, we need to put these things into real life applications. In the same way that your TikTok recommendation is on your TikTok app, it started on someone else's computer first. And then they had to figure out how to embed it into the TikTok application for you to use in person. So that's the data science life cycle. I'm going through it constantly and all the time. But for this session, we're just going to focus on the second bottom half of our life cycle, about collecting data, processing it, analyzing it, and maybe some model generation and things like that. Any questions? Let me know. And if I'm going too fast, also let me know. So everybody put your hats on, and I will need some participation for this part. Hello, data detectives. Welcome to the boardroom. You've been called upon to solve a perplexing mystery at the gallery of wonderful Shanttel. I have this gallery where I have many artifacts of me. And recently they've been vanishing without a trace. I don't know where they went. My security systems have been down, and so are the visitor logbooks. They've been compromised. I don't know what happened, but I've lost my artifacts. And we as a collective only have data science on our side. So we're gonna have to solve this mystery using a little bit of data science skills. And I think we can do it. I think we can do it. Give me a reaction if you think we can do it. Come on, let's really get into it. Let's really bring this to life. That's right. I feel you because I think we can. We have skills, including data science, and we're going to do it. So these are the examples of art that was stolen, artistic. And I want them back. Okay. So the first thing we're going to do is we're going to start. So we've kind of basically made our problem statement in that slide, if you know what I mean. So we're just going to skip right next to the different sources of data because we're going to collect data now. There's different types of data, and this is important for how we analyze it. You can see how everything kind of knocks on in effect. So there's different types of data that we can collect. The first is structured data. Structured versus unstructured is essentially, is it fixed and predefined, or is it kind of more complex to analyze? So when we talk about structured data, we mean databases, spreadsheets, on Excel, when you have A1 and D11, you can find it easily, it's nicely and organized. That's structured data. But you also have unstructured data. And to be honest, a lot of the data that we analyze and put into models, all that kind of thing, are usually kind of unstructured. Think of images and videos. If a computer only understands binary, which is just ones and zeros, how do we get it to understand a photo? You see what I mean? Like, how do we translate that? I mean, there are ways to do it, but we need to see, like, what are we collecting first and how can we translate it into computer legible data? So it's more complex, but it's not impossible. And it does not deter us. No, because we need to get those artifacts back. So, I clicked too early. Other types of data formats is that you can get your structured and unstructured data, but within that, we also need to get in a bit more, like, more intricate. So we have different other types of data formats within your structure. So you can have structured, numerical, structured time series, and things like that. So we have numerical data, which is like your straight numbers. It can be whole numbers. It can be with decimal points. That's no problem. And these are like sales figures. How many products did you sell in a month? Or temperature readings. What was the temperature yesterday? Just that number is your numerical data. We also have categorical data, which is data that is grouped. So you can have product categories like furniture, technology, bedding, yeah. But you also have other examples such as like gender and sex. So male, female, intersex, all those different identities can also be categorical because it's defining groups of things rather than a number of something. But other ones you may not have heard of is time series data. So whenever you see a graph, yeah, and it's like number of things over time, and it's just like really got lots of different points, that's usually time series. And time series is very good because you can see a trend of something over time. So that could be like stock prices. Have you ever seen like a stock graph and it's just lines going up and down? It's because they have data for every single minute or every single second. And so they plot that and it gives you a nice, smooth visual. So that's that. But also weather data. If you plot the temperature over like every minute for 3 days, you get a nice smooth line, don't you? So that's also time series data. And lastly, spatial data. That's something people never really realize that we can still analyze is spatial data, like maps. Because if you think about it, maps are 2D on like an X and a Y axis. Well, Y is up, so Y and an X axis. And we can point, the tree is here, the path is a sigmoid curve going that way. And so we can analyze spatial data as well. So given that information, what kind of data, in the chat, please, get ready with it, would you collect to solve my mystery? Because we're still thinking about that. I still want my pictures back. What kind of data would you collect? So you can describe it in terms of like the actual data you collect, like what number of people came in a day. Ooh, I just gave you one. But it can also be like the structured data or unstructured because it's like CCTV video. Just give me a couple. Image data, amazing. That is exactly the kind of thing we would use because who did it? Someone take a picture of them. So great, that's a great suggestion. I also said visitor logs, like who's come through to the museum and at what time. And we know when the theft happened, because I turned around and my face wasn't there anymore. So we can also look through those as well. Interview data, we can give that. I do like a little interview, just like so what kind of a great time did you have today? And they're like, I had a great time. So we can also look through them as well. Some people they don't give good vibes. But yes, we can collect that kind of data. And we can also look at, so CCTV, that's a big data source. Yep, see, I agree with you, Mosa. CCTV is a big data source. Surveillance footage is used quite a lot in data science. Visitor logs, like I said, who's come through, when do they come, when do they leave, things like that. Social media activity, that is data you can collect. There's a technique in data science called scraping, where you go to a website and sort of take information from that website and put it in like a nice table or something for yourself. So I can go through and look at, when did people post on my hashtag, who liked certain posts, things like that. These are all data, isn't it? Employee records. What if it's someone on the inside? I doubt it. But what if it's someone on the inside? That is also data that I can use. Now I've collected my data. I'm looking at my CCTV videos. I'm looking at my visitor logs, and there are two different types of data. So how am I going to compare a video to my spreadsheet of people coming in and out without like looking one place and the other place and one place and the other place? Because that's a long thing to do, like over 3 weeks of data. This is why we give it to the computers to do it ourselves, because we don't personally have that computing resource to complete that ourselves. But before we can compare it like that, we need to prepare the data for comparison and things like that. And that's where data cleaning, transformation, integration, data reduction, and enrichment comes in. I spend a lot of my time cleaning data or preparing data for analysis and modeling, because this is one of the most important steps, in my opinion. When you have data from the real world, it's not perfect. The whole world is not perfect. People don't fill in the time that they come in, or the video skipped 3 seconds. So it's not perfect. So we have to deal with duplicated data, missing values. Some things are just incorrect. We also have problems such as, let's say we have a column that is categorical. So let's say there's category 1, 2, and 3. Some person might write 1, the number, another person writes 1, the word. And now my computer's like, those are 2 different categories. Because that's what computers do. That is just how they do it. So you really have to make sure that you're going through and normalizing it. That's what we call normalizing the data, so that it's all the same one. And it's, if it's categorical variables, that they're all the same term. Sometimes it'll be really picky and it would see, let's say it was the favorite colors thing, capital P for pink and lowercase p for pink, 2 different categories. Thank you, computer. Thank you very much. So this is when I go through and make sure everything is in the same place. Fun fact, if you want to put image, or I think image data, into like a database, what you can do is pixel coordinates. So you convert your picture into like coordinates, and they say that the HG, like the RGB colors for each pixel, don't you? Well, you do. And so you just take those color sort of readings and put it into your table as like at the A1 pixel, the RGB colors are this, and that. So that's one way we can transform an image into just numbers and use that to compare. But again, it takes time, because you just have to, and that's just the job, So that's the kind of thing. But also things like, I want to bring your attention to here, data reduction. If I had a lot of information about group 1 and only 7 cases about group 2, it's very hard to compare like 1,000 versus 7. You're not really getting a full picture. So how do we then make group 1 smaller, but still preserving what the information was for when it was 1,000, or group 2 bigger, but not inventing things that doesn't exist in the 7 people sample? So there's a lot of statistics going on there, which is why you spend a lot of time on it, because you need to figure out what methods do you need to use, are they appropriate, and is it ready for analysis? So I've taken my CCTV data, my visitor logs, and I've put them all in one big database, ready for analysis. And I'd like you to have your little fingers ready for preparing this data for me. This is my visitors log. I don't have just me. Actually, it is just me. The ancient Egypt is just me in an Egyptian set. But John Doe says it was a great exhibit. Now, looking at my visitor logs here, how would you prepare it? Like, what things do you see are a little bit wrong that my computer would have a horrible time trying to analyze it? You can put it in the comments of what things are just not quite right about this data before I can even give it to a computer. You can look at things like the visitor ID, the names, the entry times, comments even. Big number one, Hannah, names are missing. The names are missing. If I asked my computer model to analyze by name, it would not know. It's not sorted properly. That's also another big thing. In terms of sorting, sometimes computers, if your data type, for example, is not saved as number, it will think that 4 comes before 1 because that's how it came in your data, We have to hold the hand of computers a lot before we get to ChatGPT. Like, there was a lot of humans involved holding its hand, making sure it gets to the right place, because they are literally just machines. And we had to do quite a lot of things. So going back to what Morgan and Shabana were saying about how we're not that close to technology taking over the world just yet, this is one of the reasons why, because we're holding their hands a lot. But also things like, repeated ones. Poor John Doe, his same data has been repeated constantly. So I think like 15 people have been here, but it's just the one guy. It's just the one guy. But my computer might still take that as 15 different people that comes. So when I'm preparing it, I need to remove it. The visitor IDs are inconsistent, and some of them don't have a comment, or the comment doesn't have a name, or things like that. So if I'm now analyzing, someone said, I stole it, ha, 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 ha. I don't know who that is because it's not connected to a name or things like that. But also something here in the entry time, there's inconsistency. Some of them have 9 a.m., like John Doe over here, but Jane Smith is just 10. So 24-hour format versus 12-hour format, computer's gonna have a horrible time with it. Another thing we can do is also separate out the date versus the time, because computers don't like that. So again, a lot of hand holding is required in the data prep stage because data does not come perfectly. So let's say I fixed my visitor logbook and it's looking perfect. You're not going to see it because that takes time. And I actually created this, so it took me extra time. But let's just say we've cleaned it. So we're ready to now see what is the actual data saying to us now. And this is where we are going to analyze data. So there are different ways to analyze data, and most often you're going to use pretty much all of them or most of them, or a combination of a lot of them. You know what I mean? So you don't just do, for example, linear regression. You don't just do that and then that's it for your EDA, your analysis. You don't just do that. You kind of do all of them. So we have things like descriptive statistics. So the mean, the mode, the min, the max, all those kind of things. What are those values? You also have things like linear regression, which is looking at, it's not so much correlation, but it is correlation actually. As one thing increases, how much does the other thing increase or decrease? It could be a decrease in correlation. Clustering, what things are more closer together? You can probably group them as in this is one group and is separate and distinct from these things, which are more like one group. Also, time series analysis. Again, like I said, time series is great for trends. We can see if something has seasons. Does it peak every April? Does it peak during the midday and then falls by night, and then peak again during the midday and falls by night? We can see those kind of things with time series. But also, what if I have loads of textual data? So let's say all my reviews, I can use sentiment analysis to see which ones are the positive ones, which ones are the negative ones, but also text mining. And text mining is when you extract the topics of the text. We call it corpus. That's what nearly came out of my mouth. You can extract the topics of the corpus that you're looking at. Are they all talking about the missing art? Scandalous. Or are they all talking about how it was so great and Shanttel was a great host? But that's the kind of thing you could do with your data. So this is the data we have. What kind of things would you be looking to extract from that data? Remember, we have CCTV, visitor logs, social media, employee records. Do you have any idea the type of things we want to extract from it? I can give you one. With the CCTV, I can look for, what kind of things can I look for from a CCTV image? People that walked in and out very quickly, because that's unusual, because you should take an hour and a half at my museum. But any ideas of kind of things? Let's say, for example, the visitor logs. Is there anything you'd be looking for? Visitors at a different section. Yeah, just lots of just unusual activity, isn't it? And unusual activity has a subset of data science, and we call that anomaly detection. So we can use data science to predict the pattern. What is a normal day, right? What is a normal day, and what is unusual? What is an anomaly within that normal look and atmosphere? That's something that AI can do, and is very used, especially in fraud detection. So banks, crime, all that kind of thing. What is a regular use of your account, your bank account? And what's a bit different that maybe we should investigate? Yeah, so that's the kind of thing. We can also look at social media. Forgot to bring that thing up. You know, what is an unusual spike in activity of using my my hashtag, that kind of thing? That's quite unusual, isn't it? So we can also look at that. Fun fact, what is this basketball? I have no idea, sorry. Just everything else I can probably name except this basketball. I don't know what social media that is, but I digress. So once I have my analysis done, it's not good enough for me to just leave it on my coding screen and say, yep, done. Because a lot of the results of these analysis techniques are numbers. Like they're literally just numbers. Like you do your correlation and it will say your correlation is 0.36. And my boss would say, what's that? So we have to take our analysis and make it into a visualization. Can anyone name the types of visualizations on the screen right now? Any of them? And bonus points if you can name like when we use it. That's a bonus because that's an open-ended question. But if you could just name any of the visualization techniques on the screen right now. There's a bar chart. Yes, I love a good bar chart. Never discount a bar chart. There's also the pie chart. Yep. Fun facts about the pie charts. A lot of data scientists hate them. That's just a fun fact. Just because people are not good at seeing how big or small the pie chunks are compared to each other as we think they are. They're not very good at that. So you can really mislead people with pie charts. So that's just a fun fact for you. The thermodetector, yeah, that's a heat map where you can see different like quantities of the space. The line graph, correlation analysis, perfect. Thank you, Benedict. You get extra points for that one. Line graph is used for correlation analysis. Yes, as this goes up and this goes up, what happens? Does the line go up? Does it go down? Does it go wiggly woggly? You know, things like that. A histogram, yeah, it could be, this could be like a histogram or a bar chart because we know they're slightly similar, but histograms like touch each other in terms of like the bars because it's continuous. It's a continuous scale. So it could be, but that's a great example of a bar chart. And then this last one is a word cloud. Sorry, the name escaped me for a second. It's a word cloud, and a word cloud is amazing for not simulating, but like for showing word analysis. So let's say I have looked at all my comments. What is the words that come up most? Very much used a lot of the time in comment reviews or just reviews of places, just to see what is mostly coming up before that. So I can tell in these words, teamwork, innovation, but not so much crisis, which is good. I'm glad crisis is not coming up too much. So that's the kind of thing a heat map can show. So you can use all these types of visualizations to communicate to someone who wasn't there going through the data with you, what you found. It's a quick way to communicate what your findings, but also a way to keep them engaged. So you may find something out. A graph is one of the most perfect ways to communicate what you found, because a lot of people are not experts like you. And so they needed a different way to understand what you've seen. So that's that. Now, guess what we did now? So I actually went digging in my social media post about my museum. And I plotted it on the number of mentions. So that's my x-axis. And on this axis, I have the number of mentions I have versus time. So over time, how does it look? You know, I didn't want to put numbers there because it's quite low, as you can see. Normally, it's quite a low amount, and you get spikes when I have special exhibits, you know, just special exhibits that come up, and it's just like, oh, come to my museum if you will come. But this is across all social medias. So I looked at X, formerly Twitter. I nearly said Twitter there. Facebook, Instagram, and Reddit to see how many times are people using my hashtag. And I also ran this data. So I scraped it all of the websites, scraped it, put it into a database, really processed it to see how I can make it, you know, understandable to my computer. And then I graphed it because, again, it was going to give me just a bunch of numbers. Like, I know I'm an engineer, but I'm not a computer. So I need a graph. And I graphed it to see what am I seeing. And just as Mosa also just gleaned right there, there's a huge spike right there. And that is unusual. Although I am very popular, I am not popular for a minimum amount of time. Yes. So that spike is quite unusual to the things I'm doing. And so that's when you start using the context of the thing, you know, the data about it that you know. And I realized that we knew that our artifacts were missing right about here. And then closely behind is a spike in social media. So then I have to dig back into the data. Where is this spike coming from? Who is talking about me so much then? And as you know, as predicted, it was a bunch of people saying, oh my gosh, it's gone. Why is it gone? Who stole it? But there was also an interesting discovery. I found a post actually of someone trying to sell the exact artifacts that I have lost. And that person was arraigned and caught. They were caught because it is not good or legal to steal from my artifact and try and sell them to others. So shout out to that person, they've been busted. And I got my artifacts back. Now, this is obviously an example of how people can use data to get to a solution. This example is definitely into, like, we're looking at fraud detection, crime analysis, all that kind of thing. And these kind of things are, well, this specific example is pretty much like the data team in like a police station kind of thing. But there are so many uses of data in AI. The way I use it is looking at, for example, internally, if we want to build a chatbot, that chatbot needs something to talk about. So that's when we start looking at where can we get the data to inform that chatbot, process it, and put it in a way that when we're coding that chatbot, it understands all these things and then produces an answer to people. You have to go through all these steps. And my job is pretty much all of this. Like I said, I started as a machine learning engineer at Sage, and that meant I was looking at mainly just the modeling, the machine learning, that part. And now that I'm moving into data engineering is because, well, kind of, I was too good at my job that the machines can run by themselves. I'm joking. But it's just more like we start looking at where are we getting that data from? And is that data ready to be put into the models? So I'm still working with models. I'm still like a data scientist. I'm still knees deep in statistics, but I'm also looking at what are our data sources? How do we extract from that, wrap it all up and put it to the system that we're currently using, because we're looking at things like security, ethics, governance, all that kind of thing. And that's where we're working with to put that there. So there's many, many, many different ways of applying data science. And you as young people can literally find your interest in everything. There's data science in fashion, construction, you know, just fun little silly PowerPoints like this. And if you have any questions, this is the time for it. So that's me done. Thank you very, very much.
Thank you so much, Shanttel. Really, really enjoyed that. And we already have so many questions.
Okay.
I'll start off with the first one. Someone has said, I have seen the report from the World Economic Forum that data analysis are one of the careers that are most vulnerable to be replaced by AI in the future. What are your views on this?
I think it's going to change the job. It's not going to eradicate it. I see the AI panic in the same way as when like color TV came to the scene, where people were like, it's gonna ruin the cinema industry, is going to be wiped out because people have TVs in their homes. But till today, we still have a thriving cinematic industry. So it changes the way we analyze data or the jobs that we do in data analysis. So for example, you're not cleaning all of your data yourself, for example. You may ask AI to do it for you, but you still have that job where you need to analyze it, because things like knowledge or like context, it's a human being that still needs all that kind of thing. Because remember, our AI systems are using past data to predict. Humans can create. And so we still have a role for data analysts in the future. It will be different than what it is now, but it will be there, in my opinion.
Thank you so much. We're going to move on to the next question. Someone said that they would love to be mentored by you for a data science career. Where can they get your credentials, and they're so interested in this career path? Like maybe advice on like how you can get into this career, and just maybe like your LinkedIn or anything where people
can... my name, Shanttel Kemawor, should come up on LinkedIn. If it isn't, I don't know how to send it out. But Shanttel Kemawor should be able to find it. I fell into data science because I didn't want to be a website developer. Sorry, I didn't want to code that much. And then I got here and I'm coding every day. But it really is just, I think what helped me with the career in data science is that I was able to translate data into to a wide audience. That was the biggest part of it, because I do think that the technical skills you can learn easily. You can definitely do it, but I'm also presenting in front of people. I'm also making sure that the context I know of society and everything, I'm applying to it. So it really is simply passion. It just passion and upskilling. So the more you code, the better your chances are. But if you have passion, you're like 50% there.
Thank you so much. And yeah, for anyone who like looks up your LinkedIn, I'm sure that the Teens in AI LinkedIn account will be posting this live stream where they will tag you. So if anyone can't find your LinkedIn, check the Teens in AI page. Could you give us a brief explanation of deep learning, please?
Yes. So machine learning is mostly where statistical methods are used. So your linear regression is machine learning, where we're looking at the correlation between X and Y, and does it go up, does it go down? So it's quite straightforward in machine learning. Deep learning is where we have neural nets, right? And nets is where we're looking in more like less the 2D space of X and Y, but like, what if X, Y, Z, A, B, C, and all these different dimensions? It becomes more than 3D. You can have like 300 dimensions, which is incomprehensible to the human brain, but a computer understands that. And so when we have all these dimensions, and dimensions are simply factors that affect the result, for example, so the color, the shape, where it is in time, all those kind of things, we can't comprehend how the color, the shape, the time it happened, when it happened, who's looking at it, all these kind of things affect one result. That's when we use deep learning, because the computational resource is able to comprehend all of those things and still output a result. It's why we can give it pictures of multiple different cats, and it still figures out that if I give it a new picture of a cat, this is a cat, because it's thinking about not just one color in space. It's like the size, the shape. Does it have fur? Does it not have fur? Is it on the background of grass? Is it in a building site? Things like that. So deep learning is where we get more and more complex, and we give it more and more factors that influence the results. And that's where your LLM models live, because we're giving it more and more things to think about before it comes out with a result. I hope that explains it.
Thank you so much. Going to move on to the next question. Is image data important, as not a lot of crimes are solved through CCTV, as it is a breach of privacy?
Oof, there's so many things going on there. Image data is important. Crime solving using CCTV, we have to think back to our data science model. Is the video surveillance footage that we have ready to be analyzed? A lot of the time, someone is too far away, we can't see their face, or we don't have the technological advances in that specific police station. They don't have the resources to analyze all of it. So whether it's used or not, it could be a problem of, is the data good? Is it a quality data that we can use to analyze that? Yeah, I think that's it. So it is important. You don't really hear too much about it because I feel like right now we're sort of focusing on words and that. And I think because words is just it's a little bit easier. This is an industry secret. Words analysis is easier than image. We're still figuring that out. It's why when you create an AI image, she has 3 arms and you never ask for that. So it's not less important. We're maybe less advanced in it, but it also means that in reality, people may not have access to the things that are able to analyze it that well for it to be used. So it may be a time thing, maybe soon.
On to the next question. How can data be programmed into a chatbot created by using AI?
How can data be programmed into a chatbot using AI? Okay, this is like a 6-week seminar question. Okay. So the way we do chatbots now is we give it the simplest way to create a chatbot is to take someone else's chatbot and then give it more data to be more specific to what you want it to chat about and say, only use this data. That's the simplest way to do it. If you want to take it a step back and build it yourself, that's a huge task in terms of giving it a language, for example. The way you program an English chatbot might be different to a French chatbot, for example. And we use data because the way AI and chatbots work is they see the words and the input you give it as numbers. And if it just says, okay, if I see the number sequence 111, usually what comes after it is 112. And 112 is correlated with the word, I don't know, honey, and 111 is correlated with the word bee. So it says, okay, so bees and honey. That's what it does. It doesn't see bee and honey. It sees 111 and 112. So you have to train it on lots of data to understand the relationships between the different numbers as it sees it before it now starts talking to you. And if you want it to be specific, you get more data on the topic you want it to increase its sort of outlook on something. Because remember, you can think of yourself. When you started with just your ABCs, you were great. And then we gave you more of the ABCs and you're like, okay, cool, I can create a word. And then we gave you more, and now you can understand sentences. And then more sentences meant you understood what sentences work better together, how to create complex sentences. It's the same thing, but instead of words with meaning, it's simply numbers kind of thing. So we start with numbers, we give it more and more data, and it gets more specific and specific and specific until we have what we end up with. Again, that's a topic for like 6 hours. That was condensed. So maybe one day I'll give like a seminar, not today though.
Thank you for explaining such a complex question. Next question, what are some of the biggest challenges you have to face as a data engineer? And how do you overcome them?
All right. So one thing to clarify, data engineering is an actual role and title. That's what I need to clarify. And it means that you're maintaining, deploying, and creating the pipelines to which data can flow from different sources or from a source to another. And my role does that, but I also oversee the entirety of the AI sort of network and stuff like that. So as a data engineer, the biggest challenge is simply not having the right data. That is your biggest challenge. That is literally your job. Because when you're working at work, where else? When you're working, you have strict rules on security. For example, your company only paid for Excel. So therefore, if you get like a like a JSON file that Excel can't open, how do you transform it into a file that Excel can use without compromising it or losing a space, or if it's indented wrong or words go missing? Because these things happen. That's where a data engineer would come in, figure out how to transform that data and send it to your machine. Because it's not as simple as like an email. I wish it was, there's like AWS, there's cloud you have to think about in terms of how do I send it to the cloud network and then the worker can access it from the cloud network, but not all workers because security issue and all that kind of thing. So the biggest one is just you have a data source and it's not ready to be used by the person who wants to use it. How do you transform it? And data comes in so many different forms that, and someone only just wants an Excel file, that it just becomes a big mess of things. And every day is pretty different. How do you deal with it? You have to just keep tinkering away. There's no real answer. You just keep clicking everything and hope one of them works. I'm joking. You do have processes that you're following. Sometimes you've seen this type of data before, so you know that it definitely needs transformation, but you're sitting there, your code is open all the time. You're configuring authorizations, APIs, for example, and things like that. So it comes with the time. As you keep thinking, you keep like realizing what you can and can't do, but it's pretty much everything is so different that it's different every day.
Thank you so much. On to the next question. Where can we learn more about data science?
YouTube was my biggest teacher. There's so many levels of explanations on YouTube. So I'm trying to think of a YouTuber I know, but all of them are like master's levels because that's just the level I'm at now. But even like the Alan Turing Institute, they have programs for children. Teens in AI, if you do any of their boot camps or their events, they always have some sort of AI expert around that has given up the time to explain these things. So engaging with more teens in AI events, that's definitely important as well. Like I said, the Alan Turing Institute has programs for more like novice levels. But I think YouTube is the biggest one. Just type in data science for beginners and you will find lots of different content. If you're more advanced, the channel I love, I think it's called 3 Brown 1 Blue. It's a channel that just goes through different concepts and statistical concepts as well. So those kinds of things. Talking to more industry experts. If you're on LinkedIn, message someone, be like, hi, what's your job like? And I'm sure they'll understand. They'll like reply. People are pretty, like, they want to talk about their job on LinkedIn. So that's also another place you can look.
Thank you so much. For the next question, for someone aspiring to become a data scientist or engineer, what key skills should they focus on?
Key skills to focus on: coding. Pick a language, get good, and just get comfortable with it. You'll be doing more things with it than you think. So getting comfortable with where things are, how to download a package, how to read code, how to fix code. The language most used in the industry is Python, but in my job, I've used JSON? Yeah, JavaScript, that's it. Sorry, it's because the extension is JSX. So I was thinking, wait, what's JSON? JavaScript, I've used Java, I've used HTML and CSS, so like the website languages as well. But if you've got Python, I believe you can learn the others, which is what you need. So Python there. Statistics, actually. Get your grips with like basic statistics, your mean, your mode, your max, your mins, like it will come up more than you think. And a few of like statistical models, like pick one. Like linear regression is the easiest to understand, so start there. What is linear regression? How does it work? You don't need to go into the maths of it. Ooh, I don't know about that, no. But you may need to go into what exactly is it telling me? What do the outputs mean? So that kind of thing. So the maths of data science is important. But apart from that, I think once you're coding, and also another spoiler, a lot of things come with the job, as you're given a problem, you'll figure out how to work with it. So if you're coding, you can then use your brain to figure out a solution and then code up the solution, which is what I would say.
Thank you so much. Next question. Looking ahead. Sorry, I'm just firing all these questions at you.
Yeah, no, I didn't realize there were this many.
Looking ahead, what trends do you think will rise in the next 5 to 10 years in data science? What new technologies should data scientists keep an eye out for?
I don't know. Okay, I don't know, and I'm gonna just share my thoughts because I think they are fast, but it's not that it was fast. It was more like we woke up one day and ChatGPT was everywhere, So, and even though as a data scientist, I knew that it was cooking in the background for years, it was cooking. But we woke up and now the public are really into it and they're all using it. So it's hard to say what will have that kind of virality in later years. I would say if you want to be ahead of the curve, image work is still in its infancy days, that you can catch up and learn about it now. And if you keep up with it, you might be one of the first people to really be good at using or creating image understanding AI, that kind of thing. So that's something in its infancy that I think could get bigger, but we're just not there right now. Words are a big thing right now, and it's not going to go anywhere for some time. So understanding natural language processing, all that kind of thing, because that's what leads to your LLMs. But, you know, we're still trying to make LLMs better, so it's not like it's going to go anywhere. But we're trying to integrate more data forms into LLMs. So that's where you get your image processing, all that kind of thing. But image processing is not at its best right now. So you can jump on that and be early.
Thank you so much, Shanttel. I'm gonna close the Q&A session now. Thank you so much for being here with us today. We all really enjoyed your talk and learned so much today.
Thank you so much for having me.
I just wanted to thank again our corporate partners, Sage Foundation and Red Hat, for supporting our session today. Bootcamp week is not over yet. Thank you everyone who joined, and hopefully we'll see you again tomorrow.